Okay, so we are going to go over, just continue with the note from Friday, okay, today. And then I'll give you some time, the rest of the period, once this video is complete, to work on some of the questions from today. This stuff is very important, okay? It's can be kind of challenging. We're solving here. There will be questions like this on the quiz, which is going to be on Wednesday still. We're still going to have the quiz on Wednesday. The quiz will be on Thursday's lesson, Friday's lesson, as well as the lesson that we do tomorrow. Just a short quiz. It'll probably just be 3 questions. So work on the homework from the first 2 lessons, and then as well as looking at over the homework for tomorrow. That should prepare you. But yeah, so I might as well get through these last few examples here for you so that you can start working on some of the homework. So this question here says the point. So the what we were going over on Friday was we were looking at the Cartesian, right? We're looking at radians and angle measures on the Cartesian, okay? So what we're going to do here is we're going to look at a couple questions in particular, okay? So I'm just going to read over the question to start here. As I go through the question, I'm going to kind of point out some things and kind of start to get a little sketch going here, okay? So the very first thing that you'll notice here is it talks about a point, okay? So what I'm going to do to start is I'm going to draw out my Cartesian grid. We got our y, we got our x. So where exactly is the point -3, -6? Well, it's roughly right around here. So I'm going to go -3, -6. It's roughly there, okay? And it says that that point, so let's write it in, -3, -6. It says that that point lies on a terminal arm, okay? So, well, there's our terminal arm of an angle theta in standard position. So there's our terminal arm, and it's talking about this angle here, theta, which is measured from standard position, which just means measured from our x-axis, okay? It says determine the exact values, so this is really important, but we're looking at exact values of sine, cos, and tan, okay? Then find the radian value of the angle in the interval 0 to 2 pi. Okay, so just quickly here, and you're going to see this, and you're going to see this always when we're answering questions in the Cartesian. This is super important. Okay, is to note that, and I might as well know what I'll do. I'll draw another one here. Go over here a little bit and draw kind of another one right on this line here. Here's kind of another Cartesian. Okay. And basically, if I'm looking at our angles, right, this is angle 0. I haven't moved at all. Once I move to here, what is this angle here? Well, that we know that to be 90 degrees, right? We've talked about this. That's in degrees, but we're not working in degrees. We're working in radians. And from Thursday's lesson, we know that 90 degrees, and if you want to do the conversion, you can, but 90 degrees is pi over 2, okay? If I were to continue this and do now this angle, so this full half circle, well, we know that half a circle is 180 degrees. And we know from our conversions that 180 degrees is the same as pi. Okay. Now we're going to continue going here. We have 3/4 of a circle, which is about 270 degrees. And if I were to count these out, like if I were to continue, figuring this out, what did I say? I think I said 3/4 of a circle, right? So we have our pi over 2. So we have our 1/2 here, right? 2 pi over 2, or pi. This is actually going to be, so this is going to be 3 pi over 2. Okay? So 3 pi over 2. And basically what you're thinking of is that's like pi over 2, which is 90, plus pi over 2, which is another 90, plus pi over 2, which is another 90. That's equal to 3 pi over 2. Or, if you like degrees, that's like 90 plus 90 plus 90, which is equal to 270 degrees. Okay? So these are our important values. Pi over 2 is here, pi is here, 3 pi over 2 is here. And if we complete that circle, what is a complete circle in radians? Well, a complete circle is 2 pi. So the important thing here is that the question is saying it wants the solution on the interval 0 to 2 pi. So basically within that range there on our Cartesian. Okay. All right, so we want to determine our exact values. So let's take a look. I'm going to just scroll up a little bit, and we're going to take a look at the note from Friday. So hopefully the teacher, I did put in the notes to hand out this copy of the note. So by accident, I printed the whole note. So if you don't have a copy of the note from Friday, hopefully they have been handed out by now. But what we're looking at here from this page, this summary page, is we want to know sine theta. That's what we want to know. We want to know cos theta, and we want to know tan theta. And so what you'll see here is that it's really important that we know our x coordinate, our y coordinate, and then our r value, right? There's our x, there's our y, there's our r. If I know those three things, I can write each of those ratios. So let's go down and we're going to find our r. So we're going to find each of those things. So, sorry for the zooming in and out there. Let me just get that fixed. So let's draw out kind of our triangle here, right? So what I'm gonna do is I'm gonna zoom in particularly close into here. And I'm gonna create a nice little right angle triangle, okay? Let's do it in green. So we have our nice little right angle triangle, okay? We know that this value here, the green value, is like our y. That's -6. We're going down 6 units. We know that this value here, okay, I'm going to draw a little purple line here. This is our x coordinate, which is -3. So we're going to throw a little -3 in there. And what we need to know is we need to know what we call our r value, okay? And our r value is the radius, right? If I were to, and I think I showed you this the other day, but if I were to like continue this to kind of make like a circle, that would be the radius of our circle, okay? So in order to do that, what we're going to do, all I'm going to do is I'm going to kind of draw this, r squared. So this is just Pythagorean theorem. So it's r squared. Let me just change the size of this. So we're just going to go r squared is equal to -3 squared plus -6 squared. That's equal to 9 plus 36. And if I continue, that's r squared equals 45. And so r is equal to the square root of 45. Okay? Which we can simplify that to root 9 root 5, which simplifies to 3 root 5. Okay? So we know our r value. Okay. So now that I know, right, I'm going to write out each of my values. I know what x is. X is equal to -3. I know what y is. Y is equal to -6. And r is 3 root 5. So now can I write my trig ratios? Well, yeah, I can. Sine theta is equal to y over r, which is equal to -6 over 3 root 5. Okay. Now what I'm going to do here is I just want to simplify this. So that's equal to, 6 divided by 3, that's -2 over root 5. And remember here, I do not want to have roots on the bottom, roots in the denominator. So I'm going to multiply by root 5, multiply by root 5. That gives me -2 root 5 over 5. So that's our first one. I'll do the next one. So the next one is going to be cos theta, which is equal to x over r, which is equal to negative 3 over 3 root 5. Those 3's cancel out. We get negative 1 over root 5. Multiply the top and bottom by root 5. That gives us negative root 5 over 5. That's our second one. And last but not least here, we're going to do tan. I'm just going to zoom out a little bit so I can keep those seen. So we're going to do tan theta, and that's equal to opposite. So that's y over x, which in this case is negative 6 over negative 3, which is just equal to 2. Okay. Now, so we got all our ratios. So we got these. We just figured out those things, those highlighted values. Now the last part of the question asks me to determine the radian value of the angle to the nearest hundredth. So watch this. Okay. It wants me to find theta. So I want to know what theta is equal to. I'm going to get my calculator and I'm going to show you this several ways here. So the very first way, we know that sine theta. So I'm looking at sine theta right now. We know that sine theta is equal to negative 2 root 5 over 5. So if I want to figure out what theta is, I'm going to take the sine inverse of, let's make this a fraction. Where's my fraction button? I'm going to say negative 2 root 5 over 5. What do we get? We get negative 1.1. Negative 1.1. Okay. Let's do the same thing with cos. Let's try second function cos. And let's do that of negative, I'm just going to do negative root 5 divided by 5. So instead of writing the fraction, I'm just writing division. We did not get the same thing. We should get the same thing. Why did we not get the same thing? Let me just try. So let's try this again. Second cos bracket. Let's do this as a fraction. Negative root 5 over 5. Interesting. I know why that's not working. Okay, so just give me 1 second. I'm just going to write that down. 2.03. 2.03. I'll show you why that's not working. Just a moment. Okay, and last one here, what we're going to do is we are going to determine, let's do it first, tan. So we're going to do second tan of 2. What do we get? We get 1.01. Okay, so we get 1.01. So a couple things that I want to point out here, okay, is this is giving us, let's write it the other one, 1.0. Wait, what do we get? 1.1. So notice we get 3 different answers here, okay? We get this one right here, this one, and this one. So we need to determine what is the actual solution to this question, okay? Well, let's look at our Cartesian again. So let's bring back our Cartesian. Let's draw where our angle is. Let's draw in our theta. So we're actually looking for this angle here. Okay. So how do we determine what that angle is? Well, what's really important here is you have to kind of think back to our cast rule. Okay. you got to think back to our cast rule. And with our cast rule, okay, I'll hold on to that thought for a minute. I'm going to zoom in here on sine. Okay, so with our cast rule, notice that sine theta is a negative value. Okay, sine theta is equal to a negative value. So if we think of cast, where is sine negative? Sine is negative here and here. Okay, so when I take the sine inverse, now this is really important to understand how your calculator works. When I take the sine inverse of negative 2 root 5 over 5, we got negative 1.1. That is this angle right here. Your calculator is always going to give you the angle that's closest to standard position, okay? Closest to your initial arm. So that's the value we got there. Let's move to our next one, okay? So just hold on to that thought for a minute. But remember, we don't want to know that angle. We want to know that angle. So now let's move to cos. Cos, so I'm going to do the same thing. Cos is this. Remember, so this is C-A-S-T. Notice that it's saying cos theta is a negative value. So where is cos negative? Well, cos is negative here and here. And when we took the cos inverse, what did we get? Well, we got this angle. What did we get? We got 2.03. So we got this angle to be 2.03. But we don't want to know that angle. We want to know this angle. Okay, so notice how we're still not getting our correct answer here. This is problematic, right? Because we're not getting what we want to know. We're not getting the actual angle that we want to know. So let's see if tan gave us the right thing. Okay, so tan, let's see what color. So tan, let's try and draw this. So same thing, C-A-S-T. So tan is a positive. Okay, well, where's tan positive? Tan is positive here and here. So when I took the tan inverse of 2, you'll notice or remember maybe that I got 1.1. That's that angle there. Okay, but that's not the angle we want. This is the angle we want. So the question becomes, how do I actually determine the angle in question? Well, we'll go down to here and we'll look at a couple things. So let's actually just use tan in particular. So looking at tan, we found out this little angle here, this little part here, and we found out that this was 1.1. Okay. What you might remember from grade 11 is this is what we call our related acute angle. This is really helpful because when we're solving trig, we can use our related acute to find the answer to other questions. So if I know that related acute, that angle actually happens to be the same as this angle here. So this little section here is 1.1. And if we know this little section here, that's going to be really helpful to us because guess what else we know? We know that from here, so our start to here, this half circle is pi over 2. So if I want to find what theta is, we're going to do pi over 2 plus 1.1. Okay. What I'm just going to do here is I'm going to put a big question mark there for these answers because we're not really sure which one we got, and now we're finding our actual answer. So if I add those two together, right, let's get out my calculator. We're going to go pi over, I wonder if this works, pi over 2, yes it does, plus 1.1, and we get a value of 2.67. Oh my goodness, I made an error. I apologize. Not pi over 2. hopefully somebody realized that. This half circle is pi. A half circle is pi. So that's pi plus 1.1, which is 4.24. Okay. So that is our angle theta, and that's in radians, but I do not need to write radians. So you don't need to write radians for your answer. Okay. Quite a big question. There was a lot we had to do in that one. Just important to kind of realize the process there. Okay. If you have questions about any of this, I will go over this stuff tomorrow. Okay. I can answer any questions that you have tomorrow, but please do try the homework. So this question says, find the sine, cos, and tan of any angle that measure 0, pi over 2, and pi. So we're looking at kind of special cases. We're looking at an angle of 0, an angle of pi over 2, and an angle of pi. Okay. So what I'm going to start by doing here is I'm going to start by just drawing each of these. Okay. So there's my Cartesian. Where is an angle of 0? Well, an angle of 0 would be this here. Okay. Notice that, well, what is the coordinate here? My coordinate is 1, 0. Okay. And we know that r squared, so we talk about r squared, but r squared is equal to x squared plus y squared. So r squared is equal to 1 squared plus 0 squared. So r squared is just equal to 1, or r is equal to 1, right? Take the square root. Okay, so we know our x coordinate, we know our y coordinate, and we know our r. So I can write out those three trig variables. So the sine of 0 is equal to, well, your sine is y over r, so 0 over 1, which is 0. Okay, the cos of 0, that angle, is equal to x over r, so 1 over 1, which is equal to 1. And the tan of 0 is equal to, well, y over x. Wow, keep messing that up. What's really interesting to note here, you can type this into your calculator, tan 0, cos 0, or sine 0, and you should get each of those values. What I also want you to think of maybe is how do those, for cos and sine in particular, how do those angles relate to our cos and sine graph? Right? How do those angles relate to your cos and sine graph? Well, at 0, your y coordinate is 0 for sine, and at 0, your y coordinate is 1 for cos. Okay? We can do the same thing for an angle of 90. So I'm going to do the same thing. I'm going to draw out my Cartesian. 90 degrees is to here. That coordinate is 0, 1. Your r value is going to be the same here. It's going to work out to 1 in the same way we got r in the previous question. So our x is 0 and our y is 1. So we can do the same thing. So the sine of pi over 2, well, this time it's going to be 1 over 1, which is equal to 1. The cos of pi over 2 is going to be equal to 0 over 1, which is your x over r, which is just 0. And the tan of pi over 2 is going to be equal to 1 over 1, which is just equal to 1. Oh no, whoa. I keep messing up this one. I apologize. Is 1 over 0, which is undefined. Okay, very interesting. We'll get into that. So in particular, if we look at our graphs of sine, take a quick look at, and cos, we're kind of looking here at pi over 2. Your sine graph looks like this, right? It's up at 1. And your cos graph looks like this. This would be pi over 2 here. is at 0. Okay? You can graph these. You can look at these graphs, kind of try to sketch these. We'll sketch these a lot more tomorrow. And case 3, so again, same thing here. We're going to sketch out this 180 degrees. So that's over here. My coordinate here, we're looking particularly at like my point there could be -1, 0. Okay, so that would make my r value if I did this the same way. So let's go r squared equals, I'll do it this way, -1 squared plus 0 squared. What you're going to find is you get r equal to 1. So we know our x is -1, our y is 0, and our r is 1, and we're finding these trig ratios. So your sine of pi, again, you can type that into your calculator, is going to be 0 over 1, which is 0. The cos of pi is going to be equal to -1 over 1, which is -1. And the tan of pi is going to equal 0 over 1, which is equal to 0. Okay? So that's just looking over that question there. Kind of drawing out those angles. Again, you can type those various things into your calculator and you'll see that you get those same answers. Okay? All right. We have, I think, 3 more examples to do here. Okay? 4, 5, 6, oh, maybe 4 more. All right, this one says, find the exact value of each trigonometric ratio. Okay, so how do we go about these questions here? Well, what we're going to do is we're going to draw out, and what you'll notice, hopefully you have the package. I'm just going to scroll down quick. This here is a summary of trig ratios on the coordinate plane. So notice here, and I'm just going to, you can use this. Maybe, I don't know if I'll give this to you on your test, but notice here, 0, 362 pi. Okay. Here's 90 or pi over 2. Here's 180 or pi. 270 or 3 pi over 2. Okay. Notice that it gives you the conversion for each. We have our, I'm going to go through these a little bit here for you for a minute. We have our 30. 30 is pi over 6, right? 6, and then if I go up by 30, I would get, and I'm just going to write this here, but this would be 2 pi over 6, which simplifies to pi over 3. If I go up another 30, I get to 90. If I go up, which is pi over 2, or 3 pi over 6, right? Go up another 30 to get to 120, which is the same as 2 pi over 3. Go up another 30 to 150, 5 pi over 6. Go up another 30, we get to 180, or pi, 6 pi over 6. And I could write that in there. This is the same as 6 pi's over 6. Go up another pi over 6, or 30 degrees, we get to 210. Go up another 30 degrees, or pi over 6, we get to 8 pi over 6, or, which is simplifies to 4 pi over 3. Go up another pi over 6, we get to 9 pi over 6, which is the same as 3 pi over 2. Go up another pi over 6, we get to 5 pi over 3. Okay, so you're just going up pi's over 6's there. And it also shows you the going up by 45 degrees. So here's kind of your 45 degree intervals. 45, there's another one, there's another one, there's another one. You would also here have, right, 45, 90. Okay, so it kind of gives it, just to highlight some of the key points on that unit circle there and what those degrees look like. Those are kind of important for when we're answering questions about finding exact values. So you can use this for reference for now. We'll figure out if I'm going to give this to you on your test. Okay. I just got to get my charger and plug this in. So just give me about 35 seconds. Okay, I'm back. So let's find the exact values of each trig ratio. I'm going to start by drawing out my Cartesian. Now 7 pi over 4. Well, how I do this, and I'll just kind of give you my thinking, and then I'll show you this on the grid, on the chart below. But 7 pi over 4 is 1 less than 8 pi over 4. And what does 8 pi over 4 simplify to? Well, that simplifies to 2 pi. So that means that 7 pi over 4 is just slightly less than a whole circle. Okay, so this here is 7 pi over 4. Okay, interesting. All right, so what does that mean? Well, what we're going to do is we're going to use special triangles and acute angles. So if sine of 7 pi over 4 looks like that, what would our related acute angle be? Or that angle right in there? Think about it for a second. It would be pi over 4. Okay, because one more pi over 4 would get us to 8 pi over 4, or 2 pi. So now that I know that, okay, what I can do here is I can relate this to my special triangles. Okay, and that's exactly what I'm going to do, is I'm going to relate this to my special triangles. And what special triangle has pi over 4 in it? Well, I'm going to draw it out for you here. It's this one. So if this is pi over 4, this is pi over 4, this is 1 root 2. So knowing that, what that allows me to do is that allows me to put in my my side lengths. So I know that this side here is 1. I know that this side here is also 1. And I know that this is root 2. What's really, really, really important is that you're thinking of this as a Cartesian. So this here 1, right? We're thinking of this as a point now. What is this coordinate? Well, it's over 1, because that's this side length, down 1. So 1, my coordinate should be 1, -1. So that means that this value should be -1. Okay? So now, if I want to know what the value of sine of 7 pi over 4 is, well, I know that that's just equal to, I'm just going to erase this here, that's just equal to y over r, and I know my y coordinate is -1, and my r is root 2. So that's what it's equal to. Now remember, we can't have a root on our bottom, so I'm going to multiply by root 2, multiply by root 2, I get -root 2 over 2. There's my exact solution. Now, if some of you are fortunate enough right now to have the calculator, you can type in, right? Because I am going to ask you to show your work. Okay, that's going to be very important, showing your work. However, depending on your calculator, you might be able to just do 7 pi over 4 and hit equals. And look at that. We get -root 2 over 2. Beautiful. It matches. So depending on the calculator you have, you're going to be able to check your work. Okay. Now, 11 pi over 6. Okay. Let's start by drawing that out. Where is -11 pi over 6? Well, think of that. That's really, really close to 12 pi over 6. And 12 pi over 6, well, that's 2 pi. So that's really close to negative a full circle, which if I think of negative a full circle is like this, going the opposite direction to right here. That's the angle we're referring to. And if this is negative 11 pi over 6, what's this little section left? Well, if we've gone 11 pi over 6's, 1 more pi over 6 brings us to 12 pi over 6. So my related acute is pi over 6. Immediately we should be thinking about our special triangles. Pi over 6, pi over 3. I think if we think about this correctly, I think it's 1 root 3 and 2. If I have that memorized correctly, let me double check my notes. That is correct. Okay. So now I can put in my side lengths. Can create my triangle. Notice pi over 6 is across from the side length of 1. This means this is root 3, and this means this is 2. This coordinate here should be root 3, 1. Right? Both values are positive because it's in the first quadrant. Okay? So now if I want to figure out tan, well, tan is y over x. I know my y coordinate is 1, and I know my x coordinate is root 3. Well, multiply the top and bottom by root 3, we get root 3 over 3. Okay? Hopefully this is starting to make sense. It can be a little tricky. This is a long note. I wonder how much time I have left here. All right, let's try these next couple examples. For the following values of sine, determine the value of theta. Okay? So notice here that this is telling us sine. So this is saying that this is telling us that sine of theta equals negative 1 over 2. Well, we know that sine of theta is y over r. So let's draw this out. Okay. So sine of theta is 1 over 2. So we're going to draw this. So that's our y is negative 1. And notice how it tells us our region. So we're looking between pi over 2 and 3 pi over 2. So we're looking in these quadrants on this side. So that's where our answer is going to be. Okay? So negative 1 over 2. So that's our y coordinate is negative. So that's going to be here. Okay? Negative 1. And this is our radius is 2. If we think of our special triangles, a radius of 2 is our one that we used above here. So that's this one up here. So that means this side is negative root 3. And if we continue to think of that special triangle, this side length then is, or this angle here is pi over 6. Okay. So, excuse me, what we're looking for is we're looking for this angle in particular. Okay. I'm going to zoom in a little bit and break this down into two pieces. We know that from here to here is pi. And we know that from here to here is pi over 6. So I get my answer of 5. Let's make this a common denominator. So this is going to become 6 pi over 6 plus pi over 6, which is 7 pi over 6. Okay? There's our solution. Now, you could use a calculator for that. I'll show you how to use a calculator for that at a later date. Okay? Now this one in particular, let's take a look at this next one. So this next one here is root 2 over 2. Now what's important to note here is that this is equivalent to 1 over root 2. Okay? Where this is my y and this is my r. My y is positive, and remember it has to be in this side, on this side, because of this here. So y is positive, so I'm going to draw my angle up here. It's telling me that y is 1, so this value is 1. It's telling me that my radius is root 2. And thinking about our special triangles, that leaves me with 1 over there. I know that this angle here is pi over 4. And so what I want to know is I want to know this angle here. Uh-oh. Appears my computer froze. Okay. I'm guessing this is still recording. 41 minutes. Oh my gosh. Okay. Well, it looks like we're still recording. So I don't think I said, hopefully, muttered some things under my breath. I thought that was going to delete on me, but it looks like we're okay. So we're going to continue. Let me think here. Okay, yes. So we need to figure out this angle here. Thought my computer froze. So let's think. Okay, so that's the angle we want. So how am I going to find that? Oh boy. Now I'm all messed up here. Nope. Okay, well. So what we're going to do, we're going to think about it like this. That's the angle. This is the angle that I want. I know this little angle in here. And I also know that a whole half circle is pi. So all I'm going to do is I'm going to go pi minus pi over 4. That's equal to, I'm just going to convert this to 4 pi over 4 minus pi over 4. Get a common denominator. I get 3 pi over 4 as my answer there. Okay? Let's continue. Reciprocal functions, okay? All it's asking for here is it just wants the ratio. So it says, and we'll talk more about reciprocal functions, but it says here, reciprocal trigonometric functions. The cosecant, secant, and cotangent functions are defined to be the reciprocals of the sine, cosine, and tangent functions, respectively. Let P be point xy be any point on a circle with radius r, corresponding to an angle theta in standard position. Then cosecant, so it's saying cosecant is equal to 1 over sine. So that's equal to 1. So we're just, oh my goodness. Technology is killing me right now. So that's equal to this, 1 over y over r, which is just the reciprocal. And we know what reciprocal, we looked at reciprocal. Reciprocal is just when we flip a fraction, okay? So that means that secant, let's just write secant theta is equal to 1 over x over r, which is just equal to r over x. And cotangent is the reciprocal of tangent. We know that tangent is y over x. So 1 over that is just x over y. Okay, those are your reciprocal functions. This is the main thing that we know, that this is cotangent theta is equal to that, secant theta is equal to that, and cosecant theta is equal to that. Okay, that's the important part right there. So lastly here, let's just finish up with this last, no, still 2 questions, okay. Since we can readily compute the value of a reciprocal ratio by taking the reciprocal of a primary ratio, most scientific calculators have keys only for primary trig ratios, okay? So this says find the exact values of cosecant, secant, and cotangent of 2 pi over 3. So this is giving us an angle. So it's saying here that theta is equal to 2 pi over 3. Well, this is Cartesian. We're doing this all on a Cartesian. So where is 2 pi over 3? Well, 2 pi over 3 is right here. It is pi over 3 less than 3 pi over 3. So this here is 2 pi over 3, which means that our related acute, or this little angle in here, is pi over 3. Okay. Whenever we are drawing these, we always want to create our triangle. So we're going to draw our triangle, our right angle triangle. Okay, knowing that that angle is pi over 3, this is root 3, 1, and 2. Okay, now how do I know those? I know those based on my special triangles. You really, really want to know your special triangles. Now, what else is important here? Well, it's really important that when I think of the end of this, I think of that as a point. So what is that coordinate? Well, that coordinate is actually negative 1, root 3. This is my x value. This is my y value. Okay? So I know that my x is negative 1. I know that my y is root 3. And I know that my r is 2. So can I calculate these ratios? Well, yes, absolutely I can. Cosecant of theta is equal to 2 over root 3, which if I multiply the top by root 3 and the bottom by root 3, I get 2 root 3 over 3. Okay. Let me just check this. Yep. Okay, if I want to find the secant, so that's secant of theta, well, that's r over x, so that's 2 over negative 1, or just 2. Okay, so I'm just going to circle my answers here. And if I want to find out the cotangent of theta, well, actually, what I should do, and I'll do this in just a moment, I'm doing this, and I'm doing this is x over y, so this is negative 1 over root 3, which simplifies to negative root 3 over 3, multiplying the top and bottom by root 3. Okay? Now, what I should have written here is we know what theta is, so instead of writing theta, I'm actually going to put what theta is, because theta is 2 pi over 3. Okay? And then last question, okay, because I do want to give you some time to try some questions. So I'm just going to go through this one real quick. There's a bunch for you to try here. Very, very important to try this out. This unit is tricky. It says angle theta is in standard position between 0 and 2 pi, so within 360 degrees. Given that cos theta is equal to 3 over 5, find the exact values of the other primary trig ratios and their reciprocals. Okay. So we're gonna write here. This is x over r. Okay. I'm gonna go through this one a little faster. But cos theta is 3 over 5, and it's telling us that the angle is between 0 and 2 pi. So it's actually telling us that there are 2 angles here, that theta could be this angle, and this angle. Okay. Find the exact angle. Given the trigger, find the exact value of the other primary trig ratios. If it's between there. I guess. So what we're going to do here is we're going to draw out what these angles are. So we want the exact values of the other primary trig ratios. So we're going to draw this in. I'm going to do this one in a different color, really this one in blue. Okay, now maybe you're wondering why could it be 2? Well, because of the cast rule, cos is positive here and here. Okay, so let's focus on our pink one first. It's telling us that this side is 3, this side is 5. So what is my height? Or I guess my height there is 4. 4, negative 4. Okay, and this would be 5 as well. Now, how do I know that? Because of this is a 3, 4, 5 triangle. Okay, we know that 3, 4, 5 makes a perfect right angle triangle. Okay, you could use a squared plus b squared equals c squared. So if I want to find all the trig, all the exact values, what I'm going to do here is I'm going to write them all out. So I'm going to write out sine theta, tan theta, secant theta, cotangent theta, cosecant theta. Okay, that's what it wants here. So it wants all these values. So sine theta is y over r. So this is either 4 over 5 or negative 4 over 5. So those will both give me those. Let me just pause this for 1 sec. I just got to check my solutions. Yep, we're good here. So those two solutions, this one gives me the pink one, and this one gives me the blue one. Okay, so let's go tan. And I'm just going to keep this. I'm going to keep this as pink and blue. So tan is y over r, so that's 4 over 3. And for the blue one, that's negative 4 over 3. For the next one, secant. Secant is r over x. So that's r over x. So that's 5 over 3. So there's only one solution there. For cotangent, that's going to be x over y. So that's going to be either for the pink one, 3 over 4. And for the blue one, 3 over negative 4. And cosecant, the cosecant, well, cosecant is the opposite of secant, so that's just going to be 5 over 3. Okay? And those are all of our solutions. Please try out some of the homework. This stuff can be slightly confusing. I will answer any questions about the homework tomorrow to be in class. Have a fantastic rest of your day, and we will see you all tomorrow. Goodbye.